Dear students, in the previous class, we have discussed chi-square goodness of fit test. Today, we consider another chi-square test procedure, that is chi-square independence test. Chi-square independence test. It is used to decide, based on sample data, whether two variables of a population are statistically related. Chi-square independence test, also chi-square test of association, is used to decide, based on sample data, whether two variables of a population are statistically related. To understand chi-square independence test or chi-square test of association, we first discuss two concepts. One is contingency tables. The other one is association. Contingency tables and association. So we first discuss what is contingency tables. We have learned in the beginning that once data is collected, we can group data, whether it is quantitative data or qualitative data, in the form of a frequency distribution. Frequency distribution of one variable. If we collect data of one variable, then we can arrange the data in the form of a frequency distribution. And the data obtained by observing values of one variable of a population is univariate data. Univariate data. That is data obtained for values of one variable of a population. It is univariate data. And this univariate data, once collected, can be arranged in the form of what is known as a frequency distribution. Now we consider how we group data simultaneously for two variables. How we group data simultaneously for two variables into a what is known as frequency distribution. We group data on two variables simultaneously into a frequency distribution, and such a distribution or the data obtained by observing values of two variables is bivariate data. Bivariate data. That is values of two variables, bivariate data. and the frequency distribution for a bivariate data is known as a contingency table. Frequency distribution of a bivariate data is known as contingency table, or also known as two-way table. So, frequency distribution of univariate data, frequency distribution of bivariate data is known as contingency tables, or what is known as two-way table. To explain what is a contingency table or a two-way table, let us consider data on political party affiliation and class level of students. Political party affiliation and class level. The variables are political party affiliation and class level. And let us see how this data is arranged as a contingency table, or what is known as a two-way table. We have two variables. It is a bivariate data. So, the class level and party affiliation, we assume that class level has four categories: freshman, sophomore, junior, senior, and this is a total: Democrat, Republican, others. Republican, others, and the total 1 4 1 6 4 8 3 15 5 4 3 12 3 2 2 7 9 40 40 students are taken. Two variables are party affiliation and class level, arranged as a two-way table or a contingency table. This class level has 2, 3, 4 levels. Party affiliation has 3 levels. Column totals are given. Row totals are also given. This is a contingency table. Now we have to consider what is known as association. We consider association of two variables. We consider association of two variables. Either the variables are categorical, qualitative, in which counts are considered. This is qualitative data, and the cell numbers are counts. The cell numbers are counts. One freshman is a Democrat supporter. For sophomore is Democrat supporter, like that. So we consider association for categorical, qualitative data. We also consider this in the case of quantitative data, in which the values are finitely many. That means discrete quantitative variables taking only limited number of values. These are the two cases for which we consider the concept of association. Now, roughly speaking, there is an association between two variables of a population. There is an association between two variables of a population if knowing the value of a variable imparts information about the value of the other variable. That is the rough idea of association. If you know the value of one variable and if it gives you some idea about the value of the other variable, then we will say that there is an association between these two variables. That is, knowing the value of one variable will give you information about the value of the other variable. Then we will say that there is association. Now, in the example presented, the variables are political party affiliation and class level. The population of interest is the students. Population of interest is the students. The two variables of the population are political party affiliation and class level. Now, to obtain political party affiliation within each class, suppose that we divide each entry with the column total. If you divide each entry with the column total, you will get the values as 0.167, 0.667, 0.167, 1. Here it is 0.267, 0.533, 0.2, 1. Then this is 0.14 and similar values. Each entry is divided by the column total. You will get an idea about association. Now consider the first column. The first column is for freshmen and party affiliation. 16.7% of freshmen support Democrats, 66.7% Republicans, 16.7% others. That is what you will get. Now, so we have two variables, party affiliation and class level. Information about a class level give you information about party affiliation. So there is association. Whether there is an association or not, we will see in the next session. Anyway, this distribution, that is freshmen and party affiliation. First column, the distribution of freshmen or the distribution of party affiliation among freshmen, and this distribution is known as the conditional distribution. The conditional distribution of party affiliation. Party affiliation, the person is a Democrat, freshman, Republic, freshman, others, freshman. It is the conditional distribution of the variable political party affiliation. Political party affiliation corresponding to the value freshman of the variable class level. So, conditional distribution of political party affiliation corresponding to the value freshman of the variable class level. And the total column provides unconditional distribution, also known as marginal distribution of what is known as political party affiliation for the entire population, freshmen, for the entire population, freshmen, which is called the marginal distribution, the unconditional distribution or the marginal distribution of the variable political party affiliation. So we have what is known as unconditional distribution, conditional distribution, unconditional distribution also known as marginal distribution, like that. So this is the contingency table, and this is the idea of what is known as association. And this table shows that there is an association between the variables political party affiliation and class level. Suppose that, as an example, suppose that we are given that we have no information about class level. Suppose no information about class level, then we can say that 32.5% of the students, 32.5%. If you take the totals, you will get 32.5 of the students are Democrats, as an example. But if we know the class level of the student, that the student is a junior, as an example, this 41.2% are Democrats. That means if no information about class level, the percentage of those supporting Democrats is 32.5. If the student is a junior, 41.7% support Democrats. That means the conditional distribution and the unconditional distribution are different. This is the unconditional distribution. The conditional distribution is given in each cell. So, Democrats, Republicans, others, freshmen, sophomore, junior, senior, etc. So, as conditional distribution is different from the marginal distribution, we can say that there is an association between these two variables. So, if no association, all the four conditional distributions are same as each other and will be equal to the marginal distribution also. So we will say that there is an association between two variables if conditional distribution of one variable given the other are not equal. Conditional distribution of one variable given the other is, if the conditional distribution of one variable given the other is different, not equal, we will say that there is an association between two variables. Now, given these concepts of contingency table and association, now we consider in the next class the chi-square independence test or chi-square test of association.